In this video, we will discuss question number 10 on clustering. Here, we'll be carrying out clustering in two ways. First, we'll use k-nearest neighbor matching, or k-means clustering, and then we will use hierarchical clustering. The objective of this problem is that we are given data set on a bunch of colleges, their stadium capacity, their latitude, longitude, athletic revenue, endowment, and student enrollment. Our job is to essentially form subclusters within three main clusters in this data set. So as a first step, we want these schools to be close by each other. So we'll form three geographical clusters using the latitude and longitude and applying the k-means clustering. So here, the first step is to essentially just form three regional clusters. We'll use k-means clustering and just cluster only on latitude and longitude and form three clusters. We'll normalize our input. We'll call these region 1, region 2, and region 3. Then with region 1, we will use hierarchical clustering and based on stadium capacity, endowment, and enrollment, because we've already done geographical clustering, so we don't have to repeat this with latitude and longitude. And then form four clusters from our data. And then we can use a pivot table to describe the properties of our clusters. With region 2, we will then use again hierarchical clustering to form three clusters. We'll normalize the input again. For region 3, we will form two clusters. And then part D basically talked about the merits and problems in forming 9 clusters, 4 with region 1, 3 with region 2, and 2 with region 3 in the way that we have formed them. So let's start by forming our clusters based on geography. Again, we will click on cluster, go to k-means clustering, and also note that the problem tells us that we need to have 50 iterations and 10 random starts when we are forming our clusters. So we will select these options. I just want my clusters based on latitude and longitude, so just select these two, move them in the dialog box, click on next. Then in these menus, make sure that you have 50 here, and in random starts, click on this radio button and then increase it to 10. We'll keep the seed as 1, 2, 3, 4, 5, and then click next and finish. So here we get these clusters. We can look at the summary description. We have cluster 1 with the latitude and longitude on an average given by this, cluster 2 by this, and cluster 3 by this. And we can also see that the first cluster has 46 schools. The average distance between these clusters is 6.54. The second cluster has 55 schools. The average distance is this. One way to make sure that our clusters are correctly done is that we want to make sure that our distances between the clusters is more than distances within clusters. And again, as we saw in the random starts, initial values that we start with can make a difference. So Excel Miner did 10 random starts and found that the sum of square distances of clusters was lowest with the 10. So it then formed the clustering based on this 10th random start. So here are clusters with different geographical clusterings done by Excel Miner. Now what we need to do is to basically copy and paste our attributes from our dataset to this file. This will help us maintain the cluster order, and then we can essentially delete these other values. We don't need to know the cluster distances because we have already done clustering based on geography. So I'm going to go back to my original dataset and just copy all my variables, bring them down, and then now just paste them next to my clusters. So now I have essentially repeated all my variables along with my clustering based on geography or regions. So I'm gonna now select this, make a new worksheet, and copy there. And I can essentially get rid of all of these things now. So I have my school names, and then I have their stadium capacity, latitude, longitude, which we already did, so we won't be using it again, and the other variables. And this is on which we'll be doing our regional clustering. So I'm going to first form 3 different regions based on the clusters which I just formed. So we'll go to home, we'll make this into a table. That helps it easy to filter things out, making sure that the selections through I. And now I can first choose cluster 1 or region 1, and then copy and paste this into a new worksheet. And we can call this worksheet region 1. So we now know the schools in region 1. They're essentially schools from the South: Alabama, Arkansas, Baylor, Charlotte. So this is like broadly um, the SMU, so broadly the southern regions in the US. Let's go back to this, and now we will do only region 2. And then copy this. And then this becomes our region 2. So we have Indiana, Iowa, this Minnesota, Ohio, Penn. So this kind of has some Midwest schools and some Eastern schools. This is our region 2. And then we will do the same to get our region 3. I'm gonna deselect all this and select 3. And these schools look like kind of west, northwest. So essentially western schools. So we can look at the school names, and we can tell that based on geography, we have got 3 broad clusters. Region 1 seems to be comprising of schools from the south. Region 2, schools from the east and somewhat Midwest. And then region 3 is essentially schools from the west. So now we will work with each of these regions, and then based on the problem, conduct our hierarchical clustering, normalizing the data and using Ward's method. So first, which is region 1, which consists of essentially schools from the south, we will conduct our hierarchical clustering. So we'll go here, Excel minor, go to cluster, hierarchical clustering. And now the clustering will be based on the stadium capacity, endowment, and enrollment, because we've already done geography. Click on next. Here we will use the Ward's method. We'll normalize the input data. Click on next, and we want to form 4 clusters. And then click finish. So now based on our data, we have been able to form 4 clusters, and these are kind of our cluster classifications. These are the subclusters, which again are formed initially. or the WURTS method. So these now are our 4 so-called conferences within the southern region, and that's essentially what we have to, we can see their averages using the pivot chart or pivot table. So to do the pivot table, let's click anywhere here, click on insert and then pivot table, making sure that our data is selected. It seems to be selected, and then click OK, and we want it in a new worksheet, so we're just going to click on OK. And now I'll just construct my pivot table. I want to have my rows as the clusters that we have created, so I'm going to move them here. And then as my values, I want to have stadium capacity, endowment, and then enrollment. And all these seem to be sums. I need to change these values to averages. Or I can just go here, making sure that I have averages here. So I'm going to right click, show values or summarize values by average. So this one is average. Summarize value by average again. And then summarize value by average. And this is a little unwieldy to read. These are our dollars. So I'm gonna just format these cells and then choose currency. So now we can actually see these are in thousands of dollars. So essentially this is 606 million, so close to $500 million. And then these are also in decimals, so I'm gonna make these as numbers with 2 decimal places. Or we don't really need decimal places when looking at numbers, so I can just round them off. So let's see now what we have got. Well, there's one more problem with this is that I can't really see how many teams are in each conference, so I want to just add one more column which will give me a count of teams in each of these conferences. So what I'm going to do is I'm going to drop cluster ID in my value label as well on top, and then here I'm going to just change them to summarize by count. It has done the sum again. So now we can see that our region, our conference 1 in region from the south is the largest conference with 25 schools, and on an average the stadium capacity is 72,000 students, and the enrollment is close to 30,000, and their endowment is $600 million. Then on the other extreme we have conference 4, which has only 2 schools. They're fairly large stadiums in these schools, the largest among the southern, 85,000. The average enrollment is 22,000, so not that big, but not too small either. However, their endowment is close to $3.5 billion. So this way, we first conducted our k-nearest neighbor K clustering to get 3 clusters based on region, and within region we have used hierarchical clustering to further obtain 4 clusters in region 1. You would do the same for region 2, where you will now get 3 clusters. In region 3 you will get 2 clusters. But kind of let's look at one problem. So part D of the problem asks us to comment on what problems do you see with this plan of having conferences based on just purely data methods or hierarchical clustering. In this chart, we see the problem that becomes obvious. Conference 1 has 25 schools. Conference 2 has only 4 has only 2 schools. It is impractical to have a conference with 2 schools and a conference with 25 schools. So if we were to just do a data-driven clustering, we would get these lopsided conferences. So we would have to somehow create a balance between the number of teams in each conference. But in spite of that, this is a very good starting point where we looked at geography, and then within geography we looked at similar schools based on these 3 traits. So hopefully this has clarified the importance and the implementation of clustering in Excel Miner on a very practical data set, and we've come up with our own conferences among the schools that we were given. And based on data, so we initially looked at geography, and even in geography we looked at uh, three variables of interest.